Welcome! So, you're a GCSE further math student, and you're staring down this absolute monster of a cubic equation, right? You're probably thinking, how on earth do I even start breaking this thing apart? Well, take a deep breath. Consider me your personal tutor for this explainer. Today, we're going to give you the exact tools you need to absolutely conquer algebraic long division and really master the factor theorem. Now, I know it looks horrific at first glance, like a massive jumble of letters and numbers, but honestly, it's literally just a simple repeating pattern.
Okay, here's our game plan for today. We'll cover the long division loop, finding factors with remainders, guessing that tricky first factor, avoiding common algebra mistakes, and finally, an exam verification checklist to lock in those marks.
All right, let's jump straight into part 1, the long division loop.
Let's face the beast, shall we? Dividing a massive, sprawling algebraic expression by something like x plus 2 seems practically impossible. You just can't neatly divide every single term all in one go. So, to make the impossible totally doable, we use what's called the partial division concept. Basically, when you set up your bus stop method, you just kind of ignore the constant in your divisor for a second. If you're dividing by x plus 2, we're only going to divide by the x term. We completely pretend the plus 2 doesn't exist right now. Will that give us the wrong answer? Yes, obviously. But don't stress, because we're going to adjust for that deliberate little error as we work through the steps.
So, the absolute key here is getting into a rhythm. Think of it as a 3-step chant. Step 1, divide your leading term, like say x cubed, by just the x. Step 2, multiply that new answer back by your entire divisor. That means both the x and the plus 2. This is how we correct that deliberate error we made. Step 3, subtract those newly multiplied terms from your original expression to see exactly what you're left with. And once you subtract, you literally just take what's left and run it through that exact same loop all over again for the x squared term and then the single x term. Divide, multiply back, subtract. Just rinse and repeat.
Oh, and here's a massive organization tip for your exam. To keep things visually clear and save your sanity, when you get your answer, let's say it's x squared, do not just scribble it randomly on top of the bus stop. Write it directly above the squared terms in your original expression. Keep your cubes stacked over your cubes, your squares directly over your squares, and your single x's over your single x's. It keeps your subtraction steps beautifully neat, and trust me, it prevents those silly little calculation errors that can totally derail the whole problem.
Moving right along to part 2, finding factors with remainders. Now, you might be wondering, what happens if you've done all that tedious dividing by, say, x plus 7, and right at the very bottom, you're left with a negative 120. You literally can't divide it by x anymore. You've hit a brick wall. So what does that actually mean for our equation?
Well, here is your definitive go-to cheat sheet for remainders. Point 1, if your final remainder is exactly 0, absolute victory. You have mathematically proven that your divisor is a perfect factor. Point 2, a 0 remainder also leaves a nice, tidy quadratic equation just resting on top of your bus stop, which you can then easily factorize to find your other brackets. Point 3, if you get a non-zero remainder, like that negative 120 we just talked about, it means the expression does not divide cleanly, so it is definitively not a factor. And finally, point 4, if you were just guessing the factor at the start, a non-zero remainder just means your guess was, unfortunately, wrong.
Which brings us to part 3, guessing the first factor. In a GCSE further maths exam, they are definitely not always going to gently hand you that first factor to test. Often they'll just throw a cubic expression at you and simply command you to factorize it. You have to figure out that first bracket entirely from scratch. But listen, do not just pick random numbers out of thin air. To make a highly educated guess for your first bracket, look straight at the number at the very tail end of the cubic expression, the constant. Why? Because when you finally expand your 3 target brackets, those 3 numbers inside them absolutely must ultimately multiply together to create that exact final constant. It's like a built-in clue. Let's look at a really practical example. If your cubic ends in a negative 9, your first guess absolutely has to be a factor of negative 9. That means your possible options are strictly narrowed down to 1, negative 1, 3, negative 3, 9, or negative 9. Honestly, as a quick tip, I always recommend testing 1 or negative 1 first because examiners absolutely love using those.
Now, as your tutor, I really want you to take this to heart. As the source material points out, it's actually built into the questions for the extra marks to account for having a few false starts. If you test x plus 3, do a massive page-long division, and end up with a remainder of 7, please don't panic. You didn't fail. You simply eliminated an option. Take a breath, pick the next factor from your mental list, and try again. The exam board actually knows this takes time, and they literally allocate marks for your working out.
Okay, part 4. Avoiding common algebra mistakes. Let's keep you out of trouble. Algebraic long division is basically a marathon, and there are a couple of really nasty hidden potholes on the track. The first one is the dreaded double negative trap during the subtraction phase. Say you're subtracting a negative 8x squared from a negative 16x squared. Your brain might be super tired under exam conditions and try to just squish them together to make negative 24x squared. Stop right there. Remember, taking away a negative is the exact same thing as adding. So negative 16x squared minus negative 8x squared is actually negative 16 plus 8, leaving you with negative 8x squared. You have to be highly, highly careful with your signs here. The second fatal flaw is completely forgetting the whole reason we multiply back in the first place. Remember that partial division concept? You initially divided by just the x. Well, if you put your answer on top of the bus stop and then only multiply it by x to subtract, you haven't adjusted for anything. You absolutely must multiply your partial answer by both the x and the constant in your divisor, like that +2 we mentioned earlier. That is the only way you can accurately subtract the adjusted terms and find the true remainder.
Almost there. Part 5, Exam Verification Checklist. We are entering the final phase of our mastery framework here. You've done the hard work, you've factored the cubic. Now, right before you move on to the next question, I want you to run through this simple mental checklist to guarantee you get full marks. Number 1, did you line up your x squares over your x squares to keep it all neat? Number 2, did you remember to multiply back by the entire divisor to correct your error? Number 3, did you catch every single double negative during the subtraction steps? Number 4, is your final remainder a beautiful, perfect 0? And number 5, did you remember to actually factorize that quadratic sitting on top of the bus stop to get your final 3 brackets? If you can confidently say yes to all of these, you've successfully nailed the question.
Oh, and right before we wrap up, I have the absolute ultimate time-saving tutor tip for you. If you're guessing a factor, you actually don't have to do the entire long division just to find out if it's wrong. Let's say you want to test the bracket x minus 4. Just grab your calculator and substitute a positive 4 into every single x in the original expression. If the calculator spits out a 0, congratulations, x minus 4 is guaranteed to be a factor. Then you can confidently write out the long division, knowing for an absolute fact that it will work out perfectly. It's a total game changer.
So, as we close out this explainer, I'll leave you with this final thought. Will you let higher level algebra intimidate you, or will you confidently execute this simple loop, adjust for your errors, and hunt down that highly satisfying 0 remainder? The power is entirely in your hands. And your calculators. Get out there, practice the loop, and go completely ace your GCSE further maths.